Okay, everyone, so that was a glitch. So let's just continue with question number 11 now. So when we're saying it's 1:1, which is equal, because when you're thinking about it visually, here at the start of the first triangle, it's more wide than the other one, but it covers less space at the end, while the last triangle is the complete opposite. It covers less width, but it covers a lot of space at the end. And also, if you can visually make it, like, let's say we had this and then we had that. These are the two pieces here, this and this. You get a half, or like at least in half. And if you add this, then you add this, and finally the thinnest amount, that's at least also a half. So we can say that's 1:1 and it's equal. You can also do this as an approach if you say, since anyways each square represents 1 centimeter squared, and anyways if you add them all together you can say half, so then they're both equal. So the answer is alpha 1:1. If we build a house with an area of 225 meters squared and a square field of side 30 meters, what percentage of the field is occupied by the house? So square field of side 30 meters, area of a square is again a squared, where a is the side of a square. So that means if the side of a square is 30, so 30 squared is 900. So 900. So and then there's this house of 225. So what will be the percentage? So basically, normally you can put percentages in a array of 100. So you can do 220 out of 100, since percentages are out of 100. So you can do 225 divided by 9. And then you get 25, which means, and you can divide the 900 by 9, you get 100. So 25 upon 100, which is 25%. Another way you can do is that you can simplify. So we know these are both divisible by 25, and since we know every fourth multiple of the multiples of 25 is a multiple of 100, we can find out 900 easily. We can just do 4 times 9, 36, which means it simplifies here to 36. And now 225, that's basically 25 times 8, which is 200, with another 25, which is basically 225 again. So we know that 225 divided by 25 is 9. So 9 upon 36, if you divide them both by 9, you get 1 upon 4. But I recommend the first method because it's a bit more simpler. But what method works best for you? I suggest that you should try the method that works best for you. So therefore the answer is beta 25%. One natural number must be filled into the missing box so that the following inequality holds. So the LCM, basically the lowest common multiple that you can find, is 35. So this is a common multiple, the first common multiple that you can find is this one. So 35, 3 times 7, 21. And there's something bigger than this 35, and then 5 times 7, 35, 4 times 7, 28, so 28 upon 35. Now we know the numbers between them are 22, 23, 24, 25, 26. Wait, let me just move that. 27 and 27. Now basically, when it's saying 7, we're multiplying both of them by 5. So we have to find something that's divisible by 5. The only thing that's divisible by 5 here is 25. So 25 divided by 5 is 5. So therefore it would be 5.7. So the answer is delta 5. Now Mario throws 3 ordinary dice with the numbers 1, 2, 3, 4, 5, and 6 on its faces. The 3 numbers will be multiplied together. Which of the following numbers cannot be its product? 48 is 3 times 4 times 4, 120 is 4 times 5 times 6, 180 is 5 times 6 times 6, and 216 is basically 6 cubed, 6 times 6 times 6. However, 84 is divisible by 12, but it's 12 times 7. Since if you say 6 times 2, that's 12, but there is no 7 in a six-sided die. So basically, you can't approach like that. And if you just do times 2, that's 42, and you can't get 6 times 7 again. And so therefore, you can say Vita 84 is impossible no matter which way you try it. So it cannot be a product. In the following table, each shape represents a whole number. The numbers on the shaded squares represent the sum of each row and column. What is the sum of heart plus smiley face plus crescent plus square? Now basically, if you see these small numbers, that means that these numbers are very small. Like the signs mean very small numbers. So, and since there are no numbers lined up, which means we can divide, we only have to like experiment with random numbers. So we can say this is 3, this is now, and also the trick is that since all of this is basically this, we can just do 6 plus whatever the square is. Now basically we can say that here it's 7, so we can say 2, 2, and 3. Now we can say 3, 2, 5, 1, 2, 3, and it all works. 2, 3, and then we have 6. This is actually, wait, oh no, there must be a mistake. There's a mistake, sorry. I don't exactly remember what the pattern is, but let me just tell you the square is 4. Let's say the square is 4, then this is 5, so 3, 2, 2 and 4, 3. Here we are, we're getting somewhere now. So 1, 3, and 2, 6, and then 2 plus 2, and we said yes. So that's it. And now we know this is 6, and then 6 plus the square, which is 4. 6 plus 4 is 10. Therefore, the sum is 10, which is gamma. Now, in the figure below, the square alpha has a perimeter of 32 centimeters, and the square of gamma has an area of 9 centimeters squared. What is the perimeter of square vita? So basically, this has a perimeter of 32, and this has an area of 9. Now, basically, we know 4a is the perimeter where a is in size. So if 4a is 32, divide both sides by 4, you get 8 is a, which means this is 8, this is 8, this is 8, this is 8. And now, gamma, the area for a square is a squared. So since the area of gamma is 9, a squared is 9, so you do the root to both of them. A is equal to 3, which means that all the sides are free. Again, a is the side of the square. Now, if we know that this whole thing is 8, and this is 3, we can find out this by doing 8 minus 3, which is 5, which means this is 5, this is 5, this is 5, and this is 5. Now, let's talk about the perimeter. We know the side of a square is 5, so 4 times 5, since 4a is equal to the perimeter, 4 times 5 is 20. So therefore, the answer is delta 20. Now, a driver will cover a total distance of 1,000 kilometers, and he wants all the tires of the car to be used equally. If there are 4 tires and 1 spare, how many kilometers will each tire have to cover? Now let's think. If we just have, now he has 5 tires, 4 normal tires and a spare one. Now let's just say he didn't have the spare tire, he just has 4 tires only. How that means if the distance is 1,000 kilometers, each tire is going to cover 1,000 kilometers, and 4 times 1,000 is 4,000 kilometers. So all of the tires have to cover 4,000 kilometers anyway. This is, and if the driver wants to share them equally still, that means that we're still following the 4,000 kilometers, but now with 5 tires. So the easy way, without like just writing down a lot of examples, is that you get that 4,000 kilometers, and then since there are 4 tires, 1 spare, now there are 5 tires. So 4,000 divided by 5 is 800. So each tire will cover 800 kilometers. So the answer is delta, basically. Now, question number 18. What is the sum of all positive integers which are smaller than 100? Their last digit is 3 and they are also divisible by 3. So there's some so this is 3. 3 itself is it's only 1 digit, and its last digit is 3, and it's divisible by 3. Then you have 33, 63, and 93. You can get 33 as the first bigger one, if you didn't count from 3, and then basically you have to find like a pattern between them. So then you have 63 and 93. And since like every number which is divisible by 3, its sum is the sum of its digits is divisible by 3, we can check 3, 6, 9, 12. These are the sums and they're all divisible by 3, so we know that these are the options. So we can just do 93 plus 63 plus 33. And you get 189, then add that extra 3 there. And you get 192. Therefore the answer is delta. Now, question number 19. With €24, we can buy 2 pencils, 3 notebooks, and 4 erasers. With €33, we can buy 3 pencils, 3 notebooks, and 6 erasers. How much does each notebook cost? Each notebook cost? Now I'm going to use a substitution method, but before I do that, I'm going to do this method. So I'm going to just minus them so I can find like an equation that I can substitute first. So 3x plus 3y plus 6z is equal to 33. 2x plus 3y plus 4z is equal to 24. Now this is called the elimination method. When you're doing minus, all of these become minus. So this becomes minus, this becomes minus. And if there is already minus, minus times minus is plus. So then that would become plus, but here we don't have that. Only the elimination method can only work if there is 2 variables which can cancel out each other. Like if you have plus 4 and minus 4, they cancel out because if you add them together it's 0. Same with variables. Plus x minus x equal to 0. So here there's plus 3y and minus 3y, so we can cancel that out. Normally, if you can't get any way of doing that normally, you just multiply both equations. You just multiply one equation or both equations by a specific number, and then you can cancel them out. Then you can cancel what the term you want to cancel out. Now basically we're just the cancel is 0, so we don't have to focus on that. Now we just have to do the rest. Now so 3x minus 2x is x. 6z minus 4z is 2z. So x plus 2z. And now 33 minus 24 is 9. So x plus 2z is equal to 9. So this is another equation that we're going to use to substitute. To make it easier for us, we can just go with the smaller equation. So 2x plus 3y plus 4z is equal to 24. Now we have to look at this. Now the substitution method we have to use. We look at this equation, and we find a way to make a variable equal to the value of a variable by swapping terms around the left hand side and the right hand side. Sound complicated? Let me just show you how easy it actually is. So if we want to see what x is equal to, we take the 2z to the other side, and that means whenever you take a term to the other side, basically it's sign inverses. So plus becomes minus, minus becomes plus, multiplication becomes division, and division becomes multiplication. So the plus becomes a minus here, so 9 minus 2z. It doesn't matter if the sign shows or not for addition and multiplication. You just have to still change it and inverse it. If there is no sign, just a positive number, then that means there's a plus, obviously. So x is equal to 9 minus 2z. What we have to do here now is we have to substitute this 9 minus 2z in the place of x. So 2 times 9 minus 2z plus 3y plus 4z is equal to 24. Now we just solve the equation because it's easier. And since we're finding the value of a notebook, it'll be easy to find the value of notebook now, in a way. So 18 minus 4z plus 3y plus 4z is equal to 24. Now this is the great reason why we should choose a smaller equation. Now minus 4z and plus 4z, they cancel out, leaving only 18 plus 3y is equal to 24. This is really helpful because now we can just directly find what y is, and that's a notebook. Y is a notebook, and it's asking what the notebook is, right? Yeah, it's asking what notebook is. So we minus both sides by 18, so 3y is equal to 6. Now we just do 6 divided by 3 is 2, so y is equal to 2. Therefore the answer is beta. It may be complicated, but you can look at this whole explanation again to get a hang of it. And slowly, if you do like more examples like this, then you'll become a master at these. So try and look at this method again and try to understand it when you look at it again if you want to. But if you fully understand it, congratulations. And if you fully understand it after you looked at the method, congratulations again. After you look at the method like twice or thrice, then congratulations again. When you understand it, it's perfect. It's great. So now we have to look at this question. Question number 20. The numbers in each rectangle represents their corresponding areas. Find the area of a rectangle labeled with the letter X. Remember how I say that all of the figures don't have to be to scale. We don't know if this is a square. Well, let's just say this is also a rectangle, because it might be drawn like that, but the figure might not be to scale. You never know if it is to scale unless it's given you some information. Here it's given us the areas, which is enough information to find it out. So now we have to check. So we have the areas 3, 5, and 7. What you could say here is, well, you have to find different factors, but here they're all odd and they're prime, which means that, and prime numbers are only divisible by 1 by themselves, but it's not actually like that. That only follows for whole numbers. When we get to decimals, prime numbers are just thrown away. We can divide almost any number by a decimal. So actually every number, I think. So let's look at these. Now we have 3, 5, and 7 again. Let's say we have 2.5, and then we have 2.3. No, that wouldn't work, because then that would be really confusing and not any of these. Then we can look at 5 and 7. We can say that 1.5? Yes, 1.5 I'm saying. So 1.5 times 4. Oh no, that's 6. Okay, wait. Wait. Okay, so let's say this is 2 and this is 1.5. So the width of this is 1.5 and the length of this is 2. Now, basically, if we have to find a number which when you divide 5 by 1.5, you get that. So 1.5 times 3 is 4.5. So, that doesn't work either. What were the values? This is gonna be a long day. Well, let's say that if we add this 7, 5, it's 12. Then it would be easier for us, because this whole thing, we can just say this is 4 and this is 3. That can give us somewhere to start with. Now, 7 divided by 4, basically. We put the 0 there because we know it doesn't divide exactly. 1.75. That helps, I guess. Yeah, so let's say that's 1.75. Anyways, 5 divided by 4 is a totally different thing. 5 divided by 4 is 1.25. So that's 1.25. 1.25 times 2. Oops, didn't get it. I mean, oh, you gotta be wait, free. Okay. 1.25 is not divisible by 3, which means that's wrong again. Great, like what? Why? Okay, now we're going with another way. Okay, so we have this rectangle. We say 6, 2. Because actually, it doesn't exactly have to obey the rules. If you know what I mean. So. No. I am thinking something else. I have no idea anymore. I'm gonna just put that as a doubt and continue onwards, because I don't exactly remember the dimensions. Put in the comments below if you know the dimensions on this video, and I might bring it to you this video or the next video. So, question number 21. The figure below shows a square which has been divided into 5 equal rectangles. The perimeter of each rectangle is 48 centimeters. What is the perimeter of the square? Okay, so 2 times L plus B, where L is the length of the rectangle and B is the breadth of the rectangle. But you could also say 2 times L plus W if you say width. Either way. Now basically, we know that's 48. Well, let's just say if it's breadth. So that's 48. Now we can divide both sides by 2. L plus B is 24, which means this length and this breadth or width, the sum is 24. Now it says that since there are 1, 2, 3, 4, 5, like basically 5 width or 5 breadth is equal to the length, which means that we have to find basically we can say 5 width plus length, or 5 breadth plus length. Oh, sorry, other way around. It's 6 width or 6 breadth. Either way you say 24 divided by 6 is 4. So your width or breadth is 4. Now, since we know that's 4, 4 times 5 is 20, which means the whole side is 20. So the perimeter of the square, since the side of the square is 4a, so we substitute the side. 4 times 20 is 80. Therefore, the answer is eta 80. Just for your information, because now in algebra, I've said this before, but normally the variable x, for people who don't know, people normally use a variable x, and then there's a multiplication sign, so they look awfully similar. So when you have a variable and a number next to each other, that means there's a multiplication there. Or maybe they can have a dot in between then, or like a dot between numbers, or something like that. That also means multiplication. Just for information. So yeah, now the answer is eta again. So question number 22. In the figure below, alpha, beta, gamma, delta is a square. Alpha, eta, beta, and beta, zeta, gamma are equilateral triangles. What is the value of the angle beta, eta, zeta? A lot of Greek letters, but let me explain. Okay, so this square here, it's a normal square, and every square has 90-degree angles. So we can say this is 90 degrees, this is 90 degrees, this is 90 degrees, and this is 90 degrees. But we only need to focus on this. Now we have equilateral triangles. If you can, lateral is kind of side, and equi is equal. So like equal side triangle. I think that's how the base Latin is. But yeah, basically all sides are equal in this type of triangle. And in these type of triangles, all the angles are 60, and they're free angles. So we know this is 60, 60, 60, 60, 60. Yeah, so this is 90, 60, 60, 90, 90, 90. You get the idea. So now, since we know the area of a whole circle is 360 degrees, we can just add 90 plus 60 plus 60, which is 210. 360 minus 210 is 150. So we know the angle here is 150. Since we know that all of the angles make a full circle and they add up to 360, this is technically correct. Now all the angles in a triangle, it's 180. So 180 minus 150 is 30. Now we have no idea what this type of triangle is, and if we don't know that and we are asked to work out an angle, we can just say it's isosceles. Which means that the 30 you could divide by 2 and you get 15. So this angle and this angle, they're both 15. So, but we're just focusing on this angle right here. So therefore the answer is beta 15. Now for question number 23, it's also pretty easy. In a school, there are 220 boys and 280 girls. 50% of the boys and 25% of the girls are taking part into various sports. What percentage of the students in the school are students who participate into various sports? This is easy. So, 50% of the boys, which means half of 220 is 110. And 25% of the girls. So basically, 25% is 1/4. So 280 divided by 4 is 70. So 70 girls. They're taking part in various sports. What percentage of the students in the school are students who participate in various sports? So first we have to find the amount of children in the school. Bless me, I guess. And the amount of children who are taking part in the sport. So 180. So 180 children taking part in the sports, and 220 plus 280 is 500. So 180 upon 500. Now since we know percentage, I chose fractions because again percentages can be upon 100. Basically they're out of 100 the percentages. So basically, like if you have a 99% on your exam, that means you got 99 out of 100. But it doesn't. There doesn't always have to be 100 questions. Like here. Like let's say this was a quiz. This has 500 questions. They only just divided by 5 to simplify the fraction. So we get 36 upon 100 if you divide both by 5. Basically simplification to make like simplified fractions. They're both equivalent. So that means, and since the denominator is 100, we don't care about that. We care about the numerator. So the numerator is basically 36, and then you add the percentage sign, 36%. So yeah, we just took that as like questions and quiz, but that's also actually children, and it's the same method anyway. So you get the idea. The answer is delta 36%. Question number 24. If we arrange the students of a school into rows of 3, 4, and 7, no student is left behind. If, on the other hand, we arrange the students into rows of 11, one student is missing in order to complete the last row. How many are the students in the school? Basically, what it's signifying is that if we add one more student, then the amount of children in the school will be divisible by 11. But we're talking about 3, 4, 7. So basically, what we have to do, we get 2, 5, 3. We add them all the numbers by 1, so that we can see which are divisible by 11. We know that because basically, if the first number and the last number's sum is the number in between, then it's divisible by 11. That counts for alpha, not for, anyway, also for beta. Not here, here, and not here. So now we just have to check the divisibility rules for each of them. So we got 253. Wait, we got 252, 175, and 296. Okay, these are the numbers. Now, basically, first the divisibility rule of 3. If all the digits add up to a multiple of 3, then they're divisible. This works, this works. This doesn't work. 17 is not divisible by 3. So this stops here, and we carry on with the divisibility rule of 4. Now 252, 175. If the last two digits are divisible by 4, then the number is divisible by 4. So 52 divided by 4 is 13. And now 75 divided by 4, it has a remainder. It's not divisible. So basically, that means this is wrong and stops. And the answer is 252. Beware, this question repeats a lot This question repeats a lot in the papers. Some questions always do. So it's better to solve the past papers if you want to remember, or basically the methods are the same. Now, question number 25, the last and probably kind of the easiest question. John will construct a symmetrical shape by reflecting the image of the figure below on the dotted line. Which of the following figures represents the image of his construction? Okay, let's see. Now, basically, these just meet on the point, so we can say a square is here. Now, if we want to do the exact thing, we know there's squares in between, so we put a square here, and there is a square here, and there's just one, so we could say it goes at least here, and then the last one here. So, but anyways, basically, when you have a diagonal symmetrical like this, you're basically turning the shape around by 90 degrees. Here it doesn't have no change, because when you just rotate a square by 90, 180, 270, or 360 degrees,